can either write in the chat box or just let me know. So I can see Ayush asking if he wants to learn two languages together. So Ayush, it really depends on what you want to, why do you want to learn and which application are you using them for. C is actually used for high computational reservoir simulation, or creating a software or some interface. It's having a good uh, computational, you know, it really takes less time and it has a good computational power. But if you're planning to learn data science or machine learning, it it it's advisable to learn Python. If you want to learn basic coding, the algorithms or data structures and all those, you can pick any language. C is much more robust, as I said earlier. So it really uh, it's it's really what you want to learn. You can learn basics of coding and have a good hands-on experience with C and then shift to Python. It really the concept remains the same because both are object-oriented languages. So conceptually nothing changes, but then the syntax, the style of writing, libraries, those all stuff are different. So I'll start with day 2. I share my screen.
So just a question from last class.
Yeah, tell me.
Yeah, so actually I just wanted to confirm if, for example, if we want to give the user only one chance to enter a value, and if the first chance is correct, then he's out of the game. So we can use do while loop then without using terms.
So you want user to give only one chance,
Yes.
right?
So do while will run once anyways. So we can
Yeah, you
use.
can change turns value to 1, and then the loop will only run 1, 0, and 1. So
That
you
would
can do
be
that.
something. I was just asking for a different situation. Can we use do while loop?
Yeah, you can. Yeah.
Okay, that's.
So okay, any other question? Let me know at the end of the workshop, then I'll share my screen. Okay, is it visible?
Yes, sir. The screen's visible.
Okay, great. I'll start with teaching you guys the basic library. So as I said before yesterday, that libraries are used to as a toolbox in Python. And the project that I'm planning for this workshop will use these libraries uh, in certain ways, and you'll learn more libraries, more uh, libraries as I go for day 4th and 5th. Data preprocessing is more of the the small tunings that you can do to have a good data a uniform data which you can train and have less ambiguity with the results. So let's start with pandas. You must have all heard pandas and numpy. So let's start with pandas. So pandas is basically gives you a data frame. A data frame is an organized way of visualizing a data and working on the data. You can see Excel has those blocks, right? Small code cell blocks where you can feed the data and you get a column and a row format. So that is a data frame. Now you can get many data frames, even a notepad is a data frame, but it's not really appealing to you. So pandas changes these data values that we give, that we import from some other file, maybe Excel or data file or CSV file. So what pandas does is that it changes these different file formats to appealing data frame. That's where we use pandas for the basics. And then you can read all kind of files. You can manipulate the data. You can filter the data and do all the pre-processing with pandas itself. And if you want to learn, as you can see, the advanced part of pandas, you can actually make equations, correlations, and even do the plotting. It will be a basic plotting, but then yeah, you can do it with pandas. So what I told is that data pre-processing is more of cleaning the data, getting it into the data frame, and then you use other tools such as regression or any other tool that you want to apply to that process data and then get the results. So pandas is important for pre-processing. That's why I'm teaching you pandas and some basic libraries so that you can understand data pre-processing that I'll be teaching next time. So the conventional way to import any library in Python is using this function import pandas as PD. So now anywhere you use PD dot something or PD, it'll be calling that library function from Panda, and then you'll be using that. Uh, I've shared the format. I've shared voice production data with you. Let me just give you a glimpse of how the data looks. So are you guys able to see the Excel sheet I've opened just now?
No, sir, the Excel sheet is not visible actually. It's showing the Jupyter notebook.
Just a minute. Okay, now.
Yes,
Is it visible now? Okay, great. So you can see yesterday one of the student asked me how can we use or where can we get the open source data. So if you want to really learn and apply all this stuff, you can go to Equinor site, use the beta, create an account, download the data set. It has all kind of data set that you want to learn. You can learn from Petrel to CMG to basic data analytics and data science. You have all kind of files there from which you can learn. Let's see the data because what happens is we directly import the data and we start working on it without analyzing what are the variables and what is the question or solution issue that we are looking for. So these are the production dates. These are the webboard code. Hello.
So some participants are asking for zoom in.
Sir, can you please zoom in the Excel?
Okay, got it. Okay. Yeah. So I think this is good enough. So you can see there are many variables that the company has provided openly. But you can see daily production data, monthly production data here, and then in daily you can see wellboard code, which is the well name that company is using, and then you can see the facility code, which is related to the field. You can see the facility name, which is not needed. Stream hours is the amount of time that well has been flowing. Downhole pressure, downhole temperature, tubing size, annulus size, average choke size, and all kind of data that you can see here. The volume production, the kind of flow that is happening, well type. So you can see this is the kind of data that we will need to learn. So this is the data we have seen it now. And definitely I can tell you that there will be a lot of missing data in there, or zero, or some absurd values. So you can see here 0. What happens is sometimes wells are flowing and then there is some facility constraint. Maybe the pipeline has some problem, or the refinery has some problem, or there is some weather condition or something, and well has to shut down. So it's drawn down to 0, and then stops flowing. And actually, it shouldn't be counted to the nature of reservoir, because actually it's because of some physical constraint and not the nature of reservoir. So these can be outliers that we need to work on. So uh, the basic way to read is that we use pandas here, and then we use this function read excel, which is part of the pandas library. And then we use the file name, which is stored in your folder here, to uh, to read the excel. So let's okay, I'll zoom in a little bit. So you can see this star is coming and it's loading now. And then you can use Shift plus. I'll repeat the shortcut so that it gets into your mind and you start working on it with me together, instead of going to the cell and then running. It's time consuming task. So you can load the data file name here, and actually depending upon the format of the sheet, you have to use the function accordingly. If it had been like a CSV file like this, I would have used read CSV. And you can know the type of function you have to use, just Google it depending upon the file. But as far as Excel is concerned, just use the read Excel. Now what we did is we converted this Excel file using pandas into the pandas data frame, and then just have a look at the df. So just write df here and run the code. So you can see there is all kind of the data is now in data frame. You can see how it has formatted, and it is showing the data. You can go through the data. So now it is in pandas data frame, and now you have to use tools in pandas to manipulate the data and work with the data in this data frame. So this is one function where you can have a quick look of the first five entries of the data, df.head. It actually helps sometimes, to have a look of is the data loaded, how is it, and what's the format of it, instead of loading the whole file. You can use 10 or any other number, and it will show up depending upon what you want to have, what you want to look. Sometimes the data frame is just too small, so Pandas doesn't load the whole data frame. So you can just write, if there is 15 rows, you can just write 15 and get the whole data. You can have a glance at whole. So there is another functionality with Pandas that you can actually, you can access the columns of the data frame using dot column name. So you can see the data production date here, data PRD is the column name. So if you want to access this column value, which you do need sometimes to understand the type of values and the uniqueness, or what kind of variety is in the column. So you can just write data.pred, and you can see you get all the values of the column with the length of the column, which is it has 15,634 values, and the type of value. So Pandas predicted that this is a date time kind of value. Now, if you want to access the first value of this column in this whole data frame, you can just write 1 here. If you remember, even in list, we use the same function to access the elements. So you can use this, and then you get the timestamp of the first date, which is 2014. Now, if you want to know what kind of type is this data, the first data, you can just use type, and then you can see it's a timestamp that Pandas has predicted. And these are all the small things that you might need to visualize the data. We cannot go to same Excel file again and again and then see like, hey, this is the data, and this is the date, this is the production, this is the bottom pressure. So these are the small things that you'll need to understand the data without shifting to Excel sheet actually. So now let's see the number of columns and what's the shape of the data frame, because sometimes the Excel sheet is just too big to analyze. Here you can actually just go through the, scroll around and see the data, but sometimes there are so many variables, like hundreds and 200s of variables, and you cannot go through each and every variable in the Excel sheet. So you just get the columns of the data. So here you can see these are the column names that you have got, and the point of using this function sometimes is that the column name is really important to manipulate the data. Sometimes there may be a space or some other character that we might miss in the name, and the function doesn't run. So you can see here it's between the quotation, and you can see you need DATEPRD to run to use this value. And let's have a look at the shape, which is 24 variables and 15,000, almost 15,000 rows. You can have a look at the rows and column even with this function df.shape, df.0. So if you can see, this is kind of a list, right, where you have two values, like two columns and one row. So if you understand, I'm trying to use this list and access the first column, and then this is the second column. 0 is this and 1 is this. So that's how you're using it here. Now sometimes you need to change the column name, because the names given in this Excel sheet were according to the field, to the company's norms and conditions, which might not help in understanding the code names that you're using. So sometimes companies use BHP, BHP, or they just write the full name, bottom hole pressure. So you cannot write bottom hole pressure each and every time. So you just code it according to your convenience. So I just renamed NPD field code to field code, which is the name of well. And as I have written here, the in place is necessary to change these, to save these changes. So after using in place equal to true, you actually save the data frame with the following names. Otherwise, if you are not putting in place equal to true or keeping it false, the field name is not saved. It's just saved for that particular code cell. You can try it. So you can even, now let's have a look at the info. So the thing with this function is that you can have a look at all the values and what kind of values are there, what kind of data type is there at once. So you can see the values here. Now you see there's an ambiguity that there are 9,000 values of downhole pressure, 15,000 values of on-stream mass and other variables. You can see there's a difference in values that you can see. From this, you can understand that there are some places where the values are missing actually, and then you might need to work on them, because these small null values can affect the whole data set. And then you can also see the memory usage and the type of data. So let's see the well type. Now you must have seen there was a well type in the end which showed OP, WI, and all that. So if you want to find the the number of unique values in the column, you can use well type. You can now you must have seen well-born name also. You can see the Excel sheet here. So you see well type here. There is all kind of well names. So maybe we might not be able to see some other well type which is at 7,000 or 8,000 row. So we use this to get the uniqueness, and then here you can see there are around 7 type of different wells that we'll be working on which have these names. So it's very convenient, just once you can understand what kind of wells and how many wells and what are the name of the wells, which will be very difficult in Excel. You have to use filter, and then there are a lot more other problems. So sometimes, the data frame is so big and you don't need variables, certain variables like schemas are not needed, and maybe the service provider, like here you can see, we don't need the field code, the field name because it's Valve already, and the NPD facility name. So it's really a big data frame in which we don't need certain variables. So we'll just try to eliminate them and focus the data set on those particular variables. So if I want to draw bore water volume, you choose the data frame, and in that data frame you choose the column, and then you tell which one has to be dropped. So actually what is happening here is that you are going to well-bore name and data frame, and then you're telling that in this well-bore name I want to drop these values. So you change the well-bore name here, and then you use a drop function to drop the column. That really makes it very easy to plot the function, and you have to use plt.show to visualize our data to get the value of the data. If we are not using this, you might not get you will not be able to see the plot, even though the value of the plot is stored in some variable. So you can see it's written PLT is not defined. This means our library has not been imported till now, and you can see there is a blank here, which means we haven't executed this code. So we have executed this code, and now you can see the transparency. The color code 010 is actually light green, and you can see the title, x-axis, y-axis. The limitations of y is from -4 to 5. 5 is here, and you can see the x limitation is from 0.01 to 3, which is here to here. You can change all these variables according to the certain range of plots that you need. And okay, so now see, so what happens is sometimes we have certain values and we want to plot only those values. So you can have a list of values, or maybe you want to just plot some few values. So we can just create an array of those values, and we can use XY arrays that we have created to plot them. This is an example of that. You have stored figure. You have made a you use figure function in PLT, and then you store it. So now figure is like an empty X and Y. And now you start filling this empty figure with your customization or your values. And now you have added the subplot function, which is it'll only create one plot. So you have decided the dimension and you have stored this empty plot. Now let's fill with the variables. So we have created NP array, which has these values B and D. So we have created 3 variables with these values. And then we plot. So you can see here the function is like ax.plot x, y. This is the basic function. So if you are using this, you'll see just a plot between x and y, and now you specify the other variables. You want color to be blue and line width to be 3. So this is the thickness of the line you're using in the plot. To increase this, you'll have a more thicker line. And then there is also another plot known as scatter plot, which is like specific points being plotted on the figure, unlike the plot which is joining through those points and creating a line. So this is a scatter plot. You'll see the difference between them. So here you can see we are creating 2 plots, only 2 figures in one plot. It is a little bit confusing. So you can see there are 2 plots, scatter plots here, and there is 1 line. So we are creating 2 figures in one plot. That's why I was using this plot, this function, because sometimes you need 2 different plots in 2 different figures, and sometimes you need 2 figures in same plot. It's a little bit confusing. You can try and you'll have a better understanding here. So we are using this line plot and the scatter plot together in this these 2 figures in single plot, and then you can use this function to have a look. Scatter plot is necessary when you are trying to analyze the whole set of data point and the nature of the figure. Sometimes it's not possible to draw a line or a parabola or any quadratic equation or a cubic equation. It may be an exponential function or a logarithmic function or some other complex function. So you might want to have a look at the scatter plot before going into some other different plot to analyze the data and the nature of those points. It might be in clusters. Some points will be near to x-axis, some might be on the higher side of the y-axis. All kind of possibilities are there. You'll see how the data can be visualized. I've given a small link here, which is to understand Matplot library, and you can see amazing kind of plots here that they have shown in this blog. You can have a look at it later. It will show you how to download, how to make these plots. And these are the scatter plots that I've been talking about. So you can see the nature of these plots. There are bar plots that we'll make, and then there is 3D plot, and even at this point, they are trying to create a 4D plot where you can visualize the 3D. You can actually see the 3D data varying with the time with your customization, your value. So you can see all kind of values are all kind of functions. You can see we are using func figure to control the figure level attributes, X label, Y label, title. So this is a very good source that you can learn Matplotlib. Now let's create another function. It's again the same thing. We are creating 2 figures in one plot. We have given the values x, y in this line. Marker size also. Marker size is the thickness of the point. And we have also given the marker type here. You can say it's O. So let's have a look at it. So it's having marker size default is square. So a square size 3, and you can see O, which is like the marker size we gave to the scatter plot. Yeah, and that was it. So you can have all kind of play around with this. You can see plotting x, y here, then scatter plot. We are giving the blue color line width, and marker x is giving like an x here. I haven't tried with A. I don't know if it will work. It doesn't. So there are certain kind of marker styles in this library that you have to use. X is like a small x here. And O would be like just a circle. So these are the conventional marker styles given and used in this library. Now let's have a look at creating 2 subplots together. So till now we have been using one plot and giving 2 figures on it. Now let's create 2 plots, and it's useful in comparison, as I said. If you want to compare two wells, maybe production data of two wells and maybe bottom oil pressure, you can have a better look at it. Now we are creating two plots, right? So we need two sets of plots and two sets of empty variables, which we can customize according to these plots. So I create a subplot and I store it in AX1. I create another subplot and I store it in AX2. So now we have given the value of X and Y. We have also given the type of plot, line width, and similarly the scatter plot. We have set the AX1 limitation to 0 to 5 and given the X label X1 and X2. Let's have a look at this. And I can see we have made two different plots, right? With similar values, but then it's two different figures now. So this is the difference that we have made. So actually 1, 2, 1, 1, 2, 2 is the coordinate of the plot. So 2, 1 is first column and this is second column. So we are creating actually a matrix and then giving the first position of this matrix to AX1 and the second position to AX2. Now, what if there are three subplots that we need? So it's going to be 1, 3, 1, 1, 3, 2, 1, 3, 3. So that's the way to create the third subplot. Now you can create this subplot side by side or up and down. It really depends on the position of the matrix. So if it's 2, 2, 1, you can understand it will be first row, first column, then second column, second row, right? You can understand this much better when you start experimenting all this stuff. You can see two side by side here. And now let's have two plots together and use multi-dimensional array. So let's have a look at it first. As I've told you before, we might need to create like 4 of these depending upon the situation or the visualization that you want. I've created figure and axis together in PLT subplots. We need 2 rows and 2 columns and figure size is uniform 12:7. So we have already created a template where we have 2 rows and 2 columns, and so that is four coordinates, which is 4 plots, and then given a uniform size. We have given the space between the plots and the height difference between the plots that we want to create the space between subplots. Now we set the title. So 0, 0 is the 0, 0 is the first one. We give the title this 0, 1. So you can see here it's like a matrix that we have used, and these are the coordinates, and then we are using these coordinates accordingly to set the variables. Now AX00, this is the first plot. We have given this value X and Y and then this. Now similarly AX11 scatter and this. Now we have created another function Y1, which is just list of values Y1, Y2, Y3. And we have created a for loop here. It gives the X value and then YLI. So what is YLI? We created a function Y1 here, and then we are accessing the values of this function to create the Y label. I hope you are understanding the loop here and why this was done. So what happens sometimes is that there are a lot of subplots together that we have to create. We cannot every time just do this and add it like do it 10 times because we have 10 plots. So we just created a loop which can do it in maybe 3-4 lines instead of creating 14-16 lines. And then I ran the loop to create the labels. Now what you have seen till now is that we have just given values to 1 1 and 0 0, which is this is 0 0, this is 1 1, and these are empty because we haven't given any value. We have just created an empty template. So what if I give certain values to these ones? Now we have 0 0 here. We can create 0 1 and 1 0. And you can just give like some weird value so that you can distinguish between them. Now we have given values to all the plots here. You can see. Right. We have given all the values. So let's see what happens here. Then you can see we have given values to all these plots now. Let's have a look at the color cycle. So sometimes, we are trying to plot and we need different kind of colors to create a distinction between different plots. So a range is a function that is used to create list of numbers, a list of, So let's see what is C here, okay. Now I'll just explain you this function. I haven't explained this yet. So what you can see here is that T is 0.2 to 4.8, and there is a difference of 0.2. So you can understand this is first value, this is last value, and this is the arithmetic difference between consecutive values. So if I do it maybe like 10.0, you can see it starts with 0.2 and it creates a list of numbers, an array of numbers, sorry, with difference 0.2 till 9.8, which is 10 minus 0.2. That is the last value. So I just created, a list of numbers to show you an example. Now you can see PLT plot T comma T here, X comma Y, X1 comma Y1, X2 comma Y2, and PLT dot show. You can see different color cycle, which is done automatically because you are feeding X1 comma Y1, X2 comma Y2, X3 comma Y3. Maybe you can try experimenting something else here. Let's see what happens. You can see there is another one happening. So it's PLT dot plot X1 comma Y1, X2 comma Y2, and so on. Now you must be confused that why is it taking all these arguments, because we have earlier used these kind of variables, and maybe it's possible that X1 is this and Y1 is this, and it may misinterpret it. So you see, this is a function, and these are called hyperparameters. So a function has a lot of inner parameters that it needs to run. Sometimes, for example, if you are using like a function which needs a lot of other inputs, you have those. You have this concept in machine learning that there are a lot of hyperparameters that you need to work on, like how many cycles of run you want and what kind of variables you want to use, what kind of networking you want with those with that model. So these are called hyperparameters, and this is called the function. So a function is designed where you have to use a specific parameter name and specify the value if you want to tune that function. I hope you understood this point. And then, so this is how a function works with hyperparameters. Now, you have seen here, right? We use this particular KO dash dash, which is a key that we use in plot function to create a certain kind of marker style. We are using dash line here, which is related to KOO dash dash. So you can understand this is the key that library uses to specify that, hey, we want like a dash line and not like a straight line. So similarly, there are different kind of marker styles that you can use. And you can see here is circle and a different skewed rectangle and then a circle. So these are the kind of markers that is used. These all are not a very advanced or a heavy concept, but you will need if you're trying to show it in a presentation or trying to explain someone or even write a research paper or a review paper. So this is where it's needed. There is another function called random, which is used to create random data. So just for a fact, and in computer science and actually computer algorithms, random function has been or and will be one of the most toughest function to create, because after a certain randomness, there is a correlation between data. So random function is one of the toughest function that the community has to create. So this was just a fact. So now you can see NP, and now let's have a look at what is Y. So these are just random variables that we have created, right? 15 random variables, just any random, because sometimes you need to have non-correlated data to understand the nature of the model that you are using, because correlation actually makes it difficult for you to understand your model and its behavior. So now I've created some random data and then another non-random data here with uniform values. Now I need to run this. So now you can see here we have created 15 uniform values and 15 non-uniform random values. Now let's create bar plots, because you need to have bar plots to show the comparison of between accuracies and predictions and errors. It can be anything. So this is just one of the important plots that you'll need, and you'll need even for this project. So again, we have created in columns figure sizes 1:3. You can understand it further ahead. 3 times as wide the stall. So we are now we have given the dimensions of the plot that it has to be 3 times tall and a small 1:1 third of the height width. Now we have used plot before, if you remember. We use bar h and bar to create the bar plot. Now axis 1 would be this bar plot and axis 2 would be this bar plot. Now let's have a look at this. We are creating 2 bar plots here. You can see we have used 2 columns. We have set a template of 2 bar plots. Axis 1, which is this, which specifies the position in Matplotlib. So axis 1, which is column 1, is bar plot of x comma y with color blue. And axis 2 is the bar plot. This is another kind of bar plot, bar edge, which is x comma y, face color light blue, and edge is dark blue. So you can see the edges are dark blue and the face color is light blue. Now what happens is you're confused that, hey, what's bar edge and bar? So the best way is just to write this bar edge Matplotlib. You can see there's a good documentation of what is bar edge here. They'll tell you what is bar edge and what are the variables that are being used, alignment, and other parameters. As I said before, these are the parameters that you need to specify if you need a very specific customized plot. They'll also give you other functions, and this is the horizontal bar chart. So here bar edge is like horizontal bar plot. So again here You have specified the line references that axis 1, horizontal line. It should be gray, line with a 3, which is this line. And then we have specified the vertical line and horizontal line, which is this horizontal line and this one. And then the show function to visualize and see the data. Now, just for you to understand, you must have seen oil prices like this, right? Or when you're trying to analyze the reserves of a field, you can see these are the production data or the reserve data that 2016 it was high and then the production decreased. So actually you can calculate the reserves at estimation from here and you can see how helpful this area can be. So, and it's also good for visualization. So that's why I use this example. It's very similar. You just need to use fill between to specify Matplotlib library that hey, we want edge to be blue color and face color to be light green. You can use any other color also here. You can see it's red, right? So yeah, you can use this fill function to for someone to understand. This can be like a predicted oil price, and this can be the actual oil price. Depends on what you want to use. And then plotting the dimensional array. Let's have a look at the plot and then understand. So you must be confused with what are these. What happens is that till now we have used like one-dimensional array. We have a set of numbers with which we are plotting against another set of numbers. But it's possible that we are trying to plot a matrix to another matrix to see how the data is correlating. Now, these are the data that we'll be using ahead to analyze the correlation between variables. That plot is called Pearson plot. You can have a look at it. It's called Pearson plot. It's a very important plot that we'll be using to analyze the data, analyze the correlation between the data variables. You can have a look at this, and you can comment out the line with hashtag. Now we are creating 1:3 subplot. Figure size is 10:5, giving the space of 0.5, creating a function z, which will have 15:15. So this is actually 15 into 15 values. There's 225 values. We are trying to plot 255 values using this function, subplot function. And we have color mapped it to seismic, cool, and gray. This is seismic, this is cool, and this is gray. And this is like an internal, internal conventional value that they use to specify the type of chart you want. These are like filters. So seismic filter, cool filter, gray filter. It really helps you understand the different kind of shades, explain your different kind of story. So it's actually a very great, very wide area that when you get a seismic image of a well underground, they actually use different kind of filters, like a gray filter, a yellow blue filter to understand the saturation, the faults, and all kind of variables. So actually, it's a very big tool that geoscientists actually use. That they use different kind of filters to understand the seismic, to understand the seismic data and the geological data. So each plot here tells a different story. We'll have a look at it later. It will be used in understanding variables in the regression part and the project part. Sometimes you need to upload the image, so you can use Matplotlib image function. I am sure here you are reading the JPG image. You can just upload the image here and then file, just upload the file name. Maybe I can show you this. You can see here headshot. Maybe I can use this. So I got this headshot JPG uploaded, and then you can define the X text, Y text. Text is actually the difference, not the difference, the uniformity you want in x-axis and y-axis. If it's 10 text, it will go till 10 dimensions, and then you can specify 5 text, it will go till, you're actually defining the width and the height, and then you can see the show function. So I've just uploaded my headshot. It can be any other one. Now here, I have actually, I have integrated the Matplotlib function and also the Pandas data frame and the Wolf data together to create an exercise for you guys and understand the code actually. I'm trying to make, I want you guys to try integrate pandas data frame, manipulate it, and create some subplots of the variables inside. So I have given you the function already, but I want you to understand the code actually, because unless you understand this code line by line, it'll be very difficult for you to understand and write the code on your own. And the best way is to try. So if you can see you can understand pretty much most of it, I think. You have created the figure, you have given the dimension, the title and the font size here. Now you have set the index as data breadth. You are giving Borel volume and you're giving rolling mean. So what happens with rolling mean is that, suppose it's an important concept that you will be using. Rolling mean means, suppose you have 100 points and you are trying to create a plot which has rolling mean of 10. It means for the first 10 values, it will take a mean and then that is a data point. And then next 10 is a data point. So you are actually having 10 data points, which are mean of 10 consecutive data points. So I hope you understand that. So you have created data points here, which are rolling mean, and you have set index as data bread, which is date of production, which you remember the first column was date production. So I've created the production history here of the well, which is kind of exciting for me because you can understand, you just wrote like maybe, 3 lines of code and you got the production history of the well, 1519 F1C directly. Now, you can see like if I keep repeating this one here, and then, change the well name, title name, and then here I create another function, and then I use well B, which is another well that I specify, and well C. I can actually get all the wells together in one plot and understand the production history. You can see this is another one where I'm using monthly, where the Y is Borel volume, and you're using the sum function, and you're calculating cumulative production history versus date, which is the timeline. And you can see the monthly production here, cumulative production, and this is the rolling mean production. So if you understand what is 30 here, 30 is being used for a specific task. And anyone tell me why I have used 30 here? Why have so the dates are by days, right? Why have I used 30 in this plot? Why am I using 30? Why do I need 30 days of mean? Why have I used this? Any suggestion on that? Any idea on that?
maybe months we consider
Raja, your voice is fluctuating. Maybe you can write it in the chat. Yeah, right. So exactly. That's why I use 30 here to get the monthly production data. Now you can see if it's like January, February, March, April, and you can see this is the monthly production data. That is right. So this is why I use, if we don't have, like a monthly production data, we are actually creating a monthly production data for the well using the mean value. You can also use median here. So we were lucky, we had monthly production data, so we just plotted it directly. We can also use bi-monthly production here where you are resampling into 15D and you are using the sum of that. Sum is to find the cumulative production. 30 days, what was the total production of this well? That's why we are using sum. And if you want to find a rate, like between 30 days, what was the average output of the well every day? That's why you are using mean to understand the daily basis of production. And you are using sum to understand what was the monthly or a bi-monthly production. You can also learn about, there are some interesting, there are some interesting plots such as boiling plots and box plots that you can learn from Seaborn library. We will not be using boiling plots for this workshop, but then it's a very interesting plot which tells about your statistics and variation in the data. You can also understand, you'll also, if you have gone through some papers of data science or any other statistics, you can see a lot of box plots there. These are also interesting plots which tell you about basic statistics, like where is mean, median, and what's the variation and standard deviation between the data. So it's actually a lot of math plus data visualization. And yeah, this is it, I think. You guys can ask me a question that you're confused about or you're curious about. If your internet is not working good, you can just write it in this class actually. No doubts, everyone is learning.
Yes, sir. I guess just one question in the chat box by Bishal. So can you please provide the link of the sites from where we can get the data?
Okay, yeah, I'll show you actually how it's done. So you can go to Equinor, just write Equinor wall data set. So here what you can do is you can log in as B2C, create an account, and after create an account, you can actually log in with business to customer thing and you can download the whole data. You can also download two different sites that they have mentioned. Right now, I haven't created the student account. You can actually create an account and sign in. So from here, you can download the data. It has a whole lot of data that you need as a petroleum engineer to understand and experiment and do different kind of research or learn. Yeah.
Yes, so there's another question. What does axis equals to 0 means?
Access equal to 0 means that you are using, you want the function to uh, go through rows and make the changes to rows and not columns. It might be possible that the data is actually having both the column name and a row name. So you tell the function that, hey, I want the the function or the filter to run through column wise and not row wise. So that's why use access. We use uh, access equal to 1 and 0. So 0 is row and 1 is column. You can see another one. What is different between CSV file and an XLS file? When I try to open, both of them are opening in Excel. So yeah, it depends on CSV file. You can create a CSV file and an Excel file also. Most of the time you have data, seismic data or petrophysics data in CSV format. It really depends on what kind of extension you are using. And these both are flexible with each other. CSV is comma separated value. So if you have seen any CSV file, they have a value comma a value comma. It can be also read in a notepad file or a Word file or a Excel file also. And uh, the data that we generally use in CSV format is porosity and permeability. So you have all these grid cells, right, and in a model. Now each grid cell is like 1, 1, 1, 2, 1, 3. This is the first row, then 2, 1, 2, 2, blah blah blah. That is the second row. So you create a CSV file where there's 1, 0 0.1, 0 0.2, 0 0.3 is the permeability of each cell, and that's how you create a CSV file. Excel file is a bit more heavy, you can say. CSV file is lighter and easy to read because it's just comma separated values. It's really not a big, uh, big function or file format or extension we are using. Also in scatter function, what does C equal to R do? So let me see, where is the scatter plot? Can you tell me which function exactly, which line you're talking about? Prabheet, was setting the color to red. Yeah. So red is R is like maybe the code name that we use for setting the color. Actually, these things can be just experimented. Just try maybe putting Y for yellow or G for green and see if it's happening. And if it doesn't, just so this is a long-term solution that I'm telling you. Not that I wouldn't want to answer you, but then you can always just write C equal to R Matplotlib scatterplot and just Google it. Because after this workshop is over, there will be a lot. There are so many parameters that I haven't explained you, and I cannot because such short duration. It really takes 3-4 months to understand a simple library and all the hyperparameters. So you have to start Googling it. And color cycle, why are we using T2 to and all? So you saw, right? Uh, let me show you. So I'm trying to create different functions here, which have, different nature of the function. So our first function is created as tt, which is this state function. And then you can see I've written here semi-log x, semi-log y, log. Trying to create different functions to explain you guys that, these are different kind of functions that have different color coding, which helps it easier for us to analyze. So that's why I was showing that. So it's a different kind of function that I was trying to create, because I cannot create 4 same functions and then make you understand that there's a color code. Anything else? Texas like dimensions of you can have 12 ticks in 1 year, which is 12 months. You can have 6 ticks in a year, which is 2 months together, one size. So I think you understood what is ticks here. You can divide 10 in 5 parts. So each tick is 2, and then you can create 10 with 10 parts. Each tick is 1. So it's the spacing between the x-axis and the y-axis. That is ticks. Okay. Anything else, people? Take a leave otherwise. Any feedback that I've been too fast or too slow, or I need to work on something, or explain certain concept more, slowly or something. Rolling parts. So yeah, you are taking the average of 30 points together and creating 1 point. So you're taking the whole value of whole month, which is 30 days, and you're creating a single value using the mean of all those 30 values. That is called rolling mean average, rolling mean or rolling average. You can have a look at it. Just Google it. It's not a big concept. Yeah. Yeah, to other students, is there anything that you want me to give as a feedback? I wanted to ask, I asked Preet, but is there anything else that you guys want to share? Or how has it been? And if you're learning, finding anything difficult, or you want me to work on something else? Yeah, the references that I'm giving are enough for you to learn. There's a lot of content in those sources, don't worry. Okay. Please, is it done? There are any comments in YouTube section? I'll have a look at it.
No, sir. There are not many comments or questions in the YouTube section.
Okay.
I think we are done for the day.
Okay. Yeah, I want you guys to really, have hands-on experience to really go through lines of code, because if you don't understand the first 2, 3 parts, it will be really difficult for you to understand regression and the kind of coding that we'll be doing in the project. So really dedicate yourself for the coming days. The gaps I'm giving is really for you to understand why I've given those time gaps, because you'll have to learn, read, try to execute different codes, understand what's happening, what are parameters, hyperparameters, which libraries, what are the functions that we use generally. Because once the final project and regression comes, I won't be explaining the basics of why I'm using this Pandas function or Numpy function or how am I executing it. I'll be going to the main machine learning concepts after this data pre-processing and data visualization is done. So I don't want you people to be confused that, hey, what's some function, what is mean, what is rolling average, or what are these plots? How did you get those plots? So really try to have good practice on it. You can have a lot of sources outside which are like Kaggle, can have good projects in Kaggle like to learn. You can go to Coursera, which can give you like a good content to learn. You can go to Udemy. All these courses, you don't need to go line by line or learn each and every video, but just the best way to learn what I'm teaching or what you want to learn in data science is just to code. You cannot go through books and be like, oh, I understood. I can now code. It won't be happening. You won't get the experience and the things that you'll miss while reading it. So just try to code as much as possible and read as much as possible and understand what are the errors and what are the things you need to learn. I'll take a leave now. Thank you guys. You have been good. Hello. Okay. Bye. Take care.
Thank you, sir. Thank you, sir, for this wonderful session.
Thank
And
you,
I also
sir.
want to thank all of you for attending this session. I hope you learned a lot. And let us meet again in the next session, the day 3 of the event.
Okay.
Hope I'll see
Yeah.
you all. Thank you.